Okay, a few more problems on simplifying radicals here, just to make sure that you guys are all good and we hit everything that you might see in your accelerated math. Okay, so here we have a problem where we've got one base with two different exponents, which means that we will multiply those. So what happens is I will go ahead and multiply across the top. So -2 times -1 is 2. And then on the bottom, 3 times 6 is 18. And so obviously I can reduce that and make that be x to the 1/9. So I can rewrite it like that, which it might ask me for in accelerated math. Or again, here's your index and here's your exponent. It might want me to write it as the 9th root of x to this imaginary 1 right there, which you won't really write. Either one of those might be what they would want in accelerated math. So it means the same thing. Here we have x to the -3/4 power. Again, when you have a negative exponent, that means it needs to go to the denominator. Okay, so on this particular one, that means we have 1 over the 4th root of x to the 3rd power. And now this gets a little bit tricky. Okay, we need to not have a radical in the denominator. And some people go, oh, you just multiply it by itself. And that's what you do when you have square roots, but when you have 4th roots, it's a little bit different. And so you need to think about that differently, okay? What we need to do is we need to multiply by the 4th root, and I need to put as many x's as I can in here until when I add them together, it's divisible by my index. So here's what I mean by that. See how this is an x cubed? I need to add one more x here so that when I have 3 and 1, they add up to 4. Okay, so I would want those numbers to add up to 4 or 8 or 12 or different powers of my index. Okay, so in this case, I'm going to multiply by 4 times x to the 1 power. Okay, then on the top, when I take 1 times that, I just have the 4th root of x to the 1. I'm not going to write the 1. On the bottom, I have the 4th root of x to the 4th. And now, since these numbers are divisible by each other, I can make sure that it comes out of the radical with nothing left over. So this will become the 4th root of x over x to the 1 power. 4 divided by 4 is x to the 1. Okay? And that's how that one works. Okay, slightly more complicated here, but still sort of the same process. So I will, first of all, worry about inside the parentheses first. So I am going to remember my little exponent rules, and I know these are fractions, but remember when you have an x with 2 exponents on it and they're on top of each other like this, the shortcut rule would be to subtract them. So I will take x to the -1/3 minus -6, and of course that becomes boom boom. So this is really x to the -1/3 plus 6 would be 5 2/3, which is really x to the 17/3. Okay, so on the inside I have x to the 17/3 still raised to the 1/6 power, and now I want to multiply those. So when I multiply that, I do not need common denominators. I just multiply across the top and multiply across the bottom. So this becomes x to the 17 times 1, which is 17, over 3 times 6, which is 18. Okay, it might want the answer like that, or it might want it as the 18th root of x to the 17th. And I can't pull anything out of there because 18 doesn't go into 17 and it's not in the denominator, so I don't need to try to rationalize it. Okay. And lastly, here you can't do anything with your exponents because one of your bases is an x and one of them is a y. Some people get tempted to try to subtract those exponents, but you can't unless you have the same base. So I will just go ahead and multiply both the top and the bottom exponents by that 3/4 that it's being raised to. So I will take 16 times the 3/4 power first, which gives me x to the 12th. y to the 12 times 3/4, that's what I'm doing. The 4 cancels, and so I get 3 times 3, which is 9. Just so you know, that's what I'm doing when I'm not really showing you a whole lot of work. And that is that.